Trusted by 35% of the Fortune 100, Twistlock is the world's first truly comprehensive cloud-native security platform, providing holistic coverage across hosts, containers, and serverless in a single platform. Twistlock is cloud-native and API-enabled itself, protecting all your workloads regardless of what underlying compute technology powers them. Hey, it's Alex Williams of the New Stack here today with Keith Mokris, product marketing lead at Twistlock. How are you, Keith?
I'm great. Thrilled to be here.
Thanks for joining us. Today, we're going to look at Twistlock 19.07. And as I understand, this is the 17th time you've issued a major release.
Yeah, we've been shipping releases about, 3 or 4 times a year, almost once a quarter. And so, getting closer and closer to that 20th release.
And you have quite a few interesting clients that you've built up over the past several years. Several Fortune 10 companies, Fortune 100, cabinet level agencies in the U.S. government, including the Department of Defense. I want to see what this new release is all about. Why don't we take a look?
That sounds great. I'll share my screen here and hop in.
Awesome.
Great. Is everyone able to see, what I've pulled up here in front of you? Everyone able to see the Twistlock UI?
Yeah. And I have one question before we get started. What would you say, in your own words, is the major theme of this release? What are some of the major thematic aspects of this release that you find noteworthy?
Yeah, I think there's a couple key themes. Ultimately, really tying together a lot of capabilities around real-time visibility across different areas of cloud-native infrastructure. So one of the things I'll be hopping into a little bit is our Serverless Radar that complements what we already do today for containers and hosts. So being able to now visualize serverless applications in a new way is something really exciting for us here at Twistlock. Network security in this new cloud-native world is another key point that we've been working on over many releases. Being able to do that in hybrid and multi-cloud environments in a scalable, controllable way is some other capabilities that we've brought together in this release as well. And then finally, small features that may seem really simple, like trusted images. Being able to control what images and code your developers can deploy into different environments is really a key feature for security that allows devs to go quickly. And so that's something I'm excited to highlight as well.
Terrific. Well, let's get started.
So what do we want to start with here? Cloud native network firewall?
Yeah.
Awesome. So one of the things that if you've seen Twistlock before, we've always highlighted this notion of real-time visibility across all the network connections for containers and hosts in your environment. So for example, I've built and deployed this application on Kubernetes here. If you're not familiar with it, it's the Weaveworks SockShop app, which is a really powerful Hello World application for people using Kubernetes or looking to learn about Kubernetes. And Twistlock has automatically modeled the network topology of the application by observing the native behavior of the application. So we can see how the front end talks to the user's service and then the user's database. But one of the questions that we get a lot is, how do I provide more control if one of these services connects to some outside resource? And so one of the things that you'll notice here is I've established a connection between this user's database on port 443 to this payment gateway. And so this is a new scenario where organizations, either infrastructure architects or security professionals, want an easy way to provide layer 4 microsegmentation for these hybrid or multi-cloud environments. And so this is what it looks like now in Twistlock Radar, where we're able to surface this connection by creating a really simple rule with some new entities. So for example, if I go into kind of our rules engine, you can see here I've created this rule where the user's database talks to this payment gateway on that specific port. And one of the things that's really nice is we now have this ability to create new network objects or new entities. So while you've always been able to do that for containers or hosts, we now have a way to save any of those entities So they can be used across different Twistlock users, again, on the infrastructure side or on the security side. So it's
So
really just providing a lot more control.
it's a form of reuse then, isn't it?
Yeah. And especially in these new cloud native environments where you're not just defining connections across IP addresses anymore, you need other ways to use either the image construct or something else to define those connections. And so naming things around those image identities, again, is scalable, controllable, reusable.
Because there's no real such thing in those cloud environments as a static IP address. It's always changing.
Exactly.
Excellent. So what is the evolution of the cloud native firewall in your view? What are some of the major changes we've seen in the firewalls as container architectures have become more predominant?
Sure. I think one of the questions we often get at conferences is, does this mean that my perimeter firewall is going away? And that's certainly not true. You definitely need to protect your perimeter. But when you're using either Docker or Kubernetes or other microservices type tools, you need to also manage and secure the network layer of the application itself. So being able to do that in a scalable way is one of the biggest challenges that we see in these new architectures. So how do I do this when I have tens of thousands of containers or tens or hundreds of cloud native applications? I really think that's where being able to provide micro segmentation from one container to another or across hybrid environments is really, I think, something we're going to see more and more of. And certainly has been a focus here at Twistlock.
So that's where the visualization becomes critical.
Definitely. We work with a lot of infrastructure architects in particular, where they say the ability to just see everything that has been deployed across different environments on cloud platforms is one of the most useful features that we offer. And that's why we've now made that kind of the default entry point within the Twistlock dashboard. So we used to have different kind of stats roll-ups and different deployment data, which we still do a little bit on the right side. But we now have this kind of radar view that everyone uses across different environment areas.
Excellent. So what should we look at next in terms of aspects of this new release, Twistlock 19.07?
Yeah, so one of the things I'll touch on is what we're doing for serverless. And one of the nice things you'll see at the bottom here is we have a separate tab for host radar, which we talked about in our last release, Twistlock 1903. And you'll now see that on the right, we have serverless. And so if I click over to serverless here, I now get a new view of everything we're doing around serverless functions. And so Twistlock today provides a handful of capabilities before this 1907 release around vulnerability and compliance scanning of any of the functions, zips, as you're building them with any CI tool like Jenkins. We also identify vulnerability and compliance issues in your serverless repos. So you can see what functions is my dev and DevOps team using or have deployed and their corresponding vulnerability or compliance status. We also have a way to protect functions at runtime. So you can protect them against process manipulation or network manipulation. And now we have this new visual where I can click on any function in my environment and see that vulnerability or compliance information here at the bottom and dive into that like I would before. But you also see this new purple kind of connection line where we're identifying all of those triggers like API gateways that your function is using when it's invoked. And then we're also identifying any of the services. So in this case, we're running an AWS Lambda function. So we see things like AWS CloudWatch logs or an EC2 instance that your function is connecting to or using as an outside resource. And so Twistlock does this by connecting with service tokens or other authentication methods with the API. So you don't have to configure anything here with the radar. Twistlock automatically builds out these connection components across these three panes without any work on behalf of the end user. So it's just another powerful way to see how your functions are running and communicating.
So just give me a overview of what we're looking at exactly. These are the functions basically in the middle here in these different colors. What do those different colors represent?
Sure. So just like any container or host service in the other radar, we have different colors to represent their current vulnerability or compliance status. So hopefully, most of your environment either is green, meaning that there's no compliance or vulnerability issues detected, potentially yellow, meaning you have some low risk issues. But things that are crimson or red mean that you have a lot of higher critical vulnerabilities. Things that if there's a vendor fix available, you probably want to rebuild that function or rebuild that container image. And I can click in here to the vulnerabilities tab and see essentially all of the different components that make up this Node.js function. So we can see here that this SSHPK package, has a known vulnerability with a vendor fix. And so this is an example where you'd want to potentially rebuild or redeploy that function.
Okay. And then on the right, what is the guide there? Is that just giving you, over here on the right, on what I'm looking at as the right column, when you see the impacted images, the containers, the hosts, the functions, that just provides you then that kind of glimpse that helps you kind of then provide context to the image that you're seeing.
Exactly. So, one of the challenges, you're probably sending data to be audited in services like CloudWatch, but you also may be relying on other cloud native resources on AWS, predominantly EC2 instances. And so this is an easy way where if you have functions connected to those services, we're going to highlight that, as well as other services like DynamoDB here, for example. So I can click on this DynamoDB tab and see all of the functions that are also connected to that service. So it's just an easy way to see how things are connected or communicating across your environment, which is really important in serverless environments because a lot of organizations are leveraging that as part of this kind of cloud native world, if you will. So they're not running things just on Kubernetes, but they're also, a lot of really good use cases for serverless in that world as well.
So what are you seeing in serverless? What are your customers asking you about that led you to really putting an emphasis on it in this release?
Yeah, so I think for a lot of organizations that are re-architecting applications, they may find really great use cases for Docker, containers, and Kubernetes. But for really minimal, straightforward use cases, it may really seem like a good avenue to use services like AWS Lambda and essentially just kind of skip containers altogether and run their applications, on services like Lambda or Azure Function or Google Cloud Run or something like that. And so for these applications that are really, great for event-driven computing, they're really minimal. We want to essentially tie all of that together. So being able to identify the vulnerability posture and then also provide runtime visibility and protection.
Okay. Excellent.
Yeah.
Cool.
Another feature I'd really like to highlight today is what we're doing around forensics. So one of the things that I'll identify here is Twistlock, in order to build out this radar, is building a behavioral whitelist model of how every single container, host, or function is running or designed to run by the development and DevOps team. So if I click on any microservice I have running, I can click and identify this model that might be in a learning state or in an active state correlated to each individual image. So here we've identified the SHA-256 of the image. And I can see that Twistlock has identified this process, network, file system, and system call capabilities. And what Twistlock is going to do is essentially lock down this application or alert on any sort of anomalous or nefarious activity that may happen if an attacker were trying to probe the application. And so what we've released for several releases now is this notion of what we call Flight Data Recorder and Twistlock Incident Explorer. So for example, if anything nefarious happens outside of this runtime model, Twistlock is going to isolate the kill chain of events and then is also spooling forensic data and capturing it when an incident occurs. So here we can see that this container had some sort of data exfiltration event. We can see the network activity that was part of that event. And this provides a quick glance so someone could understand, before the container is deleted or destroyed, what incident might have occurred across their environments. But this is the new view that Twistlock now provides, this timeline view of the forensic data. So I can select these different data types on the left that I want to surface in a timeline, and I can actually click through and replay or capture what happened as part of that security event. So this, really augments that kill chain to where this is all the different forensic data that was part of that potential compromise. So an incident responder or security team can better understand, was any serious data lost? How was the container misconfigured? And how can they export it to other services to, investigate this data further? So in these cloud native environments, we have a huge number of containers and cloud native applications that are connected across a lot of different, vital components. Being able to identify this data and surface it in this easy to see timeline view is something that a lot of customers have been asking for. We already surfaced this forensic data in more of a kind of filtered tabular view. So being able to surface this new timeline here is something we're really excited about.
So tell me about the timeline. And this really gets into the granularity of the data. And as I understand, there is the time series component to this, which I think is reflected in what you're showing here.
Exactly. So essentially here, I've been clicking through all of the different events that were part of this specific security incident. And you can see here that there was a specific timestamp on the left, down to essentially less than a second around what happened. There are the event details on the right, which reflect essentially what was run, on my host or container engine. We have the exact container that was part of this security incident. And so it becomes really easy to understand, what network components were involved here, what new processes were run, were there any files downloaded or accessed, or new network ports that were opened, new network connections made. This is all the data that we want to automatically collect, for the security team in diagnosing or preventing these types of incidents.
I was reading a bit about the release itself, and the detailed information that you're collecting goes beyond monitoring information, doesn't it? How does it go beyond monitoring information that you're collecting?
Sure. There's certainly a lot of data that is incredibly useful from the monitoring side. What are my containers' health? How much data is being leveraged by a specific application or container? How is my host running? But there's a different type of data that's specific to some sort of compromise or security incident. For example, what exact processes were run as part of a security incident? Or how does it impact specific cloud native services like my registry or potentially my secrets vault if I'm running that locally in my environment? And so being able to tie those things together and work with data analytics and monitoring tools to provide that full picture is really our focus here at Twistlock.
It really gets into more about observability, doesn't it? Because you need to be able to see the hardware. You need to see the data that's on the that is being collected and that is residing on the hardware. You need to be understanding what's actually in the container. You need to have information again about the host, right? You really need to be able to, and then you need that visualization with it.
Exactly. And one of the biggest challenges is how do we do all this at scale when we have hundreds of applications interconnected across environments or across hosts? And so we really want to scale that security observability, there we go, right, in a really good way for our end users.
Excellent. What else can you show us in this release?
Yeah, so one of the things that I think I really want to highlight is our feature that we call trusted images. And so one of the things that is certainly a key security requirement when you're using containers or other cloud native services is how do you ensure that development teams are deploying secure images? So vulnerability scanning is certainly one key part of that equation. But one of the other parts of the equation is how do I ensure that they have secure, non-vulnerable images to begin with? Or how do I control that as the security or audit team. And so one of the things that we've had as part of our release for a long time is this notion of trusted images, where developers may only be able to access certain base layers as they build their images, or certain repositories of images as they build their images. And you might have different repositories based on different security requirements. So for a development environment, you might be less strict in some of your security rules and what you allow in that dev or staging environment. But as you move to production, you start enforcing stronger and stronger thresholds around what can be deployed. And so one of the things you'll notice here is that Twistlock now has this shield next to this image. And Twistlock automatically can whitelist certain images that you've already deployed. So this is something that as environments are really big and different organizations have different ways of enforcing kind of this trusted image component, Twistlock allows you to set different groups of images or different whitelists based on certain things you've already deployed and approved. We can see that all of the images here are now listed as like learned to be a trusted image by Twistlock. That's what it looks like on the deployment side. But I can also come here into our policy backend and look at kind of a new trusted images rule. So if I go in here to add a new rule, I can give this new rule a name, like new rule. And what I can do is say, I'm going to allow a certain group of trusted images based on groups Twistlock has already identified. So I might say anything with the, this Weaveworks name, I'm going to automatically trust across a certain environment group. And I might say I'm also going to allow anything from Alpine in any of my environments or a specific environment. And I could hit apply here and Twistlock would allow those. And then I would just set either a group of labels or a specific host where I want to apply that rule to. I can also do this kind of in an inverse way where I might deny a certain group of images based on base layer or image source. And this comes in, really kind of reflects, for example, the Docker Hub compromise from a couple of weeks ago, where if your developers were just going out to Docker Hub, pulling down a bunch of images without scanning them, there was some sort of compromise there where a certain group of images could, bring things onto your system that you didn't want, either from a vulnerability component or a compliance requirement. And so this is one of those ways where you can start enforcing security components more easily as part of your kind of build, registry, and deployment process.
And you can do that, for example, through labels, correct?
Exactly. So you can kind of name different resources in your environment where you can apply these trusted image rules in a very flexible way that works for your organization.
So what have you seen organizations doing that this new release helps remedy? What are some examples? Because I'm sure they've been trying to, long before this announcement about Docker Hub, I'm sure they've had lots of concerns about Docker Hub just generally because of its just incredibly, by nature, frictionless environment.
Yeah, and that frictionless environment is certainly something that's exciting if you're a developer. And that's really why developers have embraced containers, because it's it's easier to build and deploy your application and package everything together in a scalable way. I think one of the big challenges comes, how do I start segmenting my environment where if I'm a security person, I want to get some control over at least the initial building blocks for my developers. And so we've really seen two challenges where sometimes developers have already been building their applications on Docker or with containers. And the security team essentially says, okay, I'm trying to play catch up here. How do I whitelist the things that have already been built and deployed because I'm confident that they're secure? And then going forward, give developers essentially a group of images or a set of trusted images that they're now going to build on for specific environments. So I think there's this notion of how can I be flexible to work with the developers while also taking away some of those initial security concerns. And it's really a balance across the organization.
Yeah, it really is. Excellent. And so what we're looking at here then are the images, the hosts. I mean, if you wouldn't mind just going back just to review.
Yeah.
You can set your allow groups. You can set the deny groups. You can select, you can really even create your own custom messages for blocked requests. These must be based upon the discussions you've had with a lot of your customers who, as you know, we noted at the top of the call, have very large, complex organizations.
Yeah, exactly. So I think, one of the things is if we can take away, some of the biggest security gaps for our customers, we know that that's going to help them tremendously control what happens across their development pipelines.
Excellent. Well, what else would you like to show?
Yeah, so I think one of the things I'd love to highlight is what we're doing around our enhanced support for Windows.
Mm-hmm.
So Twistlock has long supported a set of vulnerability management and compliance capabilities for organizations that are using Windows containers and Windows hosts. And what we've shipped with Twistlock 1907 is a set of specific compliance checks for those environments. So for example, I'm here again in my backend rules engine, and I can see that I've picked, from the different options I have here, specific checks from the Twistlock Labs research team to enforce various compliance components around your Windows configuration. So for example, do I have Windows Defender running in my environment? Do I have Windows Defender antivirus enabled? What are some of those other components that are part of this initial Windows Defender config that I want to essentially alert on or turn off based on my own decision-making process? So you can implement these compliance controls, again, as part of your deployment best practices or part of how you want to look at your environment. We've also augmented a lot of our threat and intelligence data to get a better idea of vulnerability management for specific Windows environments. So here I am looking at data in my live environment, and I can see here that I have a high risk issue for this Microsoft.NET framework, which is part of my the Windows host I've deployed. So here I can see all of the specific risk factors for this Windows host. So this is essentially not only what do I know about this vulnerability in this .NET framework, but so, is the vulnerability of critical severity, which it is? Is there a vendor fix? And then what do we know about the vulnerability? Is it something that leads to remote code execution? Was the vulnerability announced recently? So essentially, how do we start building a picture of this vulnerability data, which is something that we've augmented in this release. And at the same time, we've shipped more micro-segmentation capabilities for Windows. So we're really trying to bolster all of those Windows capabilities across the platform.
And as Windows usage increases for container deployments.
Exactly. So obviously Linux containers and Linux hosts have kind of been dominating a lot of use cases, but there are certainly a lot of customers and a lot of users leveraging Windows. And so we want to support that just like we would anything else.
Right. So that's why you have this production version of CNNF for Windows, the compliance checks, the augmentation of Microsoft Security Response Center, support for Jenkins on Windows, I see, and enhanced risk scoring for Windows vulnerabilities and Windows Server 2019 support. It's actually quite a list.
Yeah, and it's really something where we've added a lot of key capabilities across the product where there might not be one headline feature from that list, but it's really about bolstering all of these key capabilities that we've been shipping over time, augmenting that threat data, integrating with a lot of those like Windows Defender components, and then again, providing that layer 4 micro-segmentation, CNNF.
Well, how should we wrap up here?
Yeah, so I think the biggest thing is, we're really excited to be shipping, Twistlock 1907. We're really excited for our customers who are already using Twistlock and hope people have really enjoyed today's demo.
So we've seen all these different features. Well, what do you want to leave us with?
Yeah, so I think I just want to leave everyone with, there are a lot of really exciting things happening across the cloud native ecosystem. Whether it's with things like Knative, with service meshes, whether it's with serverless, and we really want to be that platform that ties all of this data together in a secure way. And so we really feel like this release brings a lot of those features together around what we see as our core platform pillars: automation, visibility, and prevention.
Automation, visibility, and prevention. And as the cloud native community grows, you'll be continuing to look at more use cases. I expect serverless for sure. And as we start looking at more Windows, I expect we'll see more release updates with that. I can see kind of the roadmap ahead by kind of just what you were showing here today.
Yeah, we're really excited about it. I definitely think you would say, cloud native isn't slowing down anytime soon. And so we, are really excited about not just this release, but everything that may be coming.
Well, thank you so much for your time today, Keith. It's been a lot of fun talking with you, and we look forward to following up soon.
Awesome. Thank you so much.
I've been here with Keith Mokris, Senior Product Marketing Manager at Twistlock. Thanks for joining us.
Great. Have a good one, everybody.
Bye-bye.
Trusted by 35% of the Fortune 100, Twistlock is the world's first truly comprehensive cloud-native security platform, providing holistic coverage across hosts, containers, and serverless in a single platform. Twistlock is cloud-native and API-enabled itself, protecting all your workloads regardless of what underlying compute technology powers them.